Okay, hello guys, I hope you're doing well. This is section 15.5, complex fractions. So we continue with simplifying fractions. So let me give you the definition of complex fractions. So complex fractions are expressions containing one or more fractions in numerator, denominator, or both. So how they look like, okay? I like to call them like step fractions. Example of complex fractions. Let's say you may have 1 over AB and everything it's over 2 over B. That's a complex fractions. So you have fraction divide by fraction, okay, but they look like a steps. That's when you guys hear me to doing KCF, keep, change, flip, okay? So you take the first fraction, you change that division to multiplication, and you flip over the second fraction. So that's what we're going to apply here. Or different example of complex fraction, you may have 1 plus 3 over 4 minus 1 over 6 over 1 half plus 1 over 1/3. So this is also example of complex fraction, okay? So your numerator has fractions and denominator has fractions. And of course, the major fraction bar, it's a division. So we're going to simplify complex fractions in this section. So I'm going to write the steps for you guys when I'm working with examples. Usually my technique to simplify complex fraction is simplify numerator, simplify denominator, and then simplify the final product. Okay, so example 1, simplify complex fractions. So I'm going to give you little tools, little hints with each example. So let's do the first one. You have 6x over y over 9 over 2y. So what I recommended first, I want you to find always like where's the middle. Okay, so find the middle of that complex fraction. So this is the middle. So that means this is your fraction bar, and you may consider that this is your numerator. So you have fraction divide by fraction. Okay, so this is the middle. So what we're going to do first, okay, so step 1, rewrite the division, because this is division. The fraction bar means division. The division as a multiplication. Okay, that's where I'm going to talk about keep, change, flip, which means keep the first fraction, C stands for change, the division, which is the pink fraction bar, to multiplication, F stands for flip the bottom fraction, which technically flip means, again, multiply by reciprocal. And then we'll simplify. Okay, so my first fraction, again, hope you guys can also see them, that this is first fraction and this is the second fraction. Okay, so you have fraction divide by fraction, keep, change, flip. We're going to keep the first fraction, which is 6x over y. We're going to change this division to multiplication. Okay, so that's c. And we're going to flip over the bottom part. So the fraction 9 over 2, 9, you're going to flip it over, so you'll end up with 2y over 9. So now this one looks much, much better. So your step 2 will be multiply two fractions. So you're going to multiply numerators and multiply denominators together. You're going to multiply denominators. Okay, so let's go back to our problem. We have 6x over y times 2y over 9. We multiply fractions, so that will be 6x times 2y over y times 9, which is the same as 9 times y. And the last step will be factor, okay? Simplify. So step 2, step 3. Step 3, simplify by factoring both numerator and denominator, if possible, of course. If you can't factor, that means your expression is prime. So let's go back to our problem. We have 6x times 2y over 9 times y. So first of all, you guys have a multiplication and you can definitely cancel y. Okay, so 6 you can rewrite as 3 times 2, and then you have x, and you have times 2, and 9 you can rewrite as 3 times 3. So common factors, you have 3 on the top, 3 on the bottom, that will cancel, and there is no more factors which we can cancel. So now we just multiply. 2 times 2 will give you 4 times x, which is 4x over 3. And that will be the final answer. Okay, so always reduce your fraction. Let's do more examples. Okay, let's do B. The next example, you have 3 over 4 minus 1 over 6 plus 2 over 1/3 plus 1/2. So this example is different than example A. Example A, you had that fraction divide by fraction. So I applied that keep, change, flip. Here, numerator has fractions and denominator has fractions. So you need to simplify each, okay, before we will simplify the final answer. So in this example, step 1 will be simplify the numerator by finding, and look what happened, our fraction has in numerator have different denominators, so by finding LCD, okay, maybe not this one, by finding common denominator, by finding common denominator, and that common denominator will be LCD of denominators which you guys have, which is LCD of 4 and 6. Okay, so let's do step 1. So LCD of 4 and 6, least common divisor, which means the number which can divide 4 and 6, that will be 12. Okay, so but just showing work to find the LCD of 4. 4 is the same as 2 to a second power. 6 is the same as 2 times 3. So LCD of 4 and 6 is, so the factor which repeats, it's 2, okay? But you're taking the one which has the highest exponent, so you have 2 to a second power. And again, you can't skip the remaining factor. We still have 3 right here, so we need to multiply that by 3. And you will get 12. So our LCD is 12, which means the common denominator is 12. So what we're going to do, how we're going to simplify? We're still on step 1. I don't want to write too many steps. So next, when you find the common denominator, okay, so next what you're going to do, rewrite each fraction from the numerator using equivalent fractions with LCD equal 12 as a common denominator. Okay, so we have 3 over 4. Okay, so our first fraction is 3 over 4. We know the common denominator will be 12. It's 12. We find that. So 12. So from 4 to get 12, of course, you need to multiply 4 by 3. Since you multiply denominator by 3, you also have to multiply numerator by 3. So now we're having 3 times 3. That will give you 9. So 3 over 4 is the same as 9 over 12. I'm going to do the same thing to 1 over 6, which is the second fraction. So 1 over 6, we're building equivalent fraction, which will have denominator equal 12. So from 6 to get 12, I need to multiply 6 by 2. Since I multiply denominator by 2, I also have to multiply numerator by 2. So here we'll multiply. 1 times 2 will give you 2. So 1 over 6 is the same as 2 over 12. And I'm building equivalent fraction, then you have plus 2. So 2, it's the whole number. You can always rewrite as 2 over 1. So we're building equivalent fraction, which needs 12 as a new denominator. So 1 will have to be multiplied by 12, and 2 will have to be multiplied by 12. Okay, so 2 times 12 will give us 24. So 24 over 12 is the same as 2. So now when we have the same common denominator, which is 12, we're going to simplify this numerator. So again, we're still working on numerator, okay? So we're going to simplify numerator. 3 over 4. So we have 3 over 4 minus 1 over 6 plus 2 is equivalent to 3 over 4 is the same as 9 over 12 minus 1 over 6 is equivalent to 212 plus 2, which is the same as 24 over 12. So we have common denominator, so we can simplify this. You copy denominator once, and you're just working with numerators. So you follow the operations. 9 minus 2 plus 24, and that will give us 31 over 12. Okay, so 31 over 12, it's numerator. Okay, so what I did right now, I simplified this numerator, 3 over 4 minus 1 over 6 plus 2. Okay, so that's all those steps were step 1. Step 2, simplify the denominator. The same thing by getting the common denominator. And of course, then you will simplify. So denominator here, it's 1 over 3 plus 1 half. So this is our denominator. So 1/3 plus 1 half. Okay, so denominator, it's 3 and 2. So you have to find LCD of 3 and 2. So think about the number which can divide 3 and 2. So LCD will be 6. 6 can divide 3, 6 can divide 2. Also, since 3 and 2 are prime numbers, so to find that least common divisor, which is our common denominator, you just multiply them. 3 times 2 will give you 6. So LCD, it's 6, which means 6 is our common denominator. Okay, so what we're doing, so I'm not going to rewrite the same steps, but we're doing the same steps like in step 1. Now you need to create equivalent fraction using common denominator, which is 6. So 1/3, okay, has to be multiply top and bottom by 2 to get 6 as a common denominator. And then we multiply, 1 times 2 will give you 2. So 1/3 is the same as 2 over 6. And 1 half, you're building equivalent fraction, which has denominator equal to 6. So 1 half will have to be multiplied top and bottom by 3 because we want to get 6 in our new denominator. And we'll multiply 1 times 3, we're getting 3. So now we're going back to the fraction from denominator. So we have 1/3 plus 1 half, which is the same as 2 over 6 plus 3 over 6. Now we have common denominator, which is 6. Copy 6 once and add numerators. and that will give you 5 over 6. Okay, so this is denominator. Okay, shortcut. So what we're going to do next? Step 3. When we simplify, we write the original complex fraction using simplified form of numerator and denominator. So I'm going back. We simplify numerator right here, and we end up with 31 over 12. So we got this. This is 31 over 12. This is simplified form of the numerator. Okay, don't forget that our complex fraction looks like that. So now I'm copied that pink fraction bar. Okay. Now we simplify the denominator. 1/3 plus 1/2 is the same as 5 over 6. So I copy that 5 over 6. Okay, so this is numerator, this is denominator. So now what you're going to do, apply keep change flip. Okay, so step 4, apply keep change flip. Okay, this is our shortcut in our class. Keep, so we're doing that here. Keep the top fraction, 31 over 12. Change means change this division to multiplication. And flip will be flip over the bottom fraction. So when you flip 5 over 6, you will end up with 6 over 5. And now you just multiply. You have fraction times fraction, so you multiply. Multiply numerators and you will multiply denominators. So you're getting 31 times 6 over 12 times 5. Factor, simplify, your fraction should be reduced. So to see that better, I'm going to rewrite 6. I'm going to keep 6 the way it is. I'm going to rewrite 12 as 2 times 6 times 5. So you guys can see that we can reduce this fraction by 6. We can divide each by 6. And that will give you 31 over 2 times 5, which is the same as 31 over 10. And this is the final answer. So not really too many of new steps here. The problems are just longer because we need to simplify numerator and denominator. Now let's talk about example 3. So I have a little more for you. Okay, example 3. So we have complex fractions. So simplify the complex fraction. So the same idea, I think I'm just using one method, which I think I don't want to confuse anybody. I think it's the best. Simplify numerator, simplify denominator, and then apply keep change flip. So we have 1 minus 1 over p over w plus w over p. Okay, so again, the middle, always find the middle. This is your fraction bar. So we have a fraction divide by fraction. Okay, so I will put it this one, that this is numerator of that major fraction and this is denominator. So step 1, simplify the numerator. Okay, so numerator, it's 1 minus 1 over p. So you need to get common denominator. What is good about this problem that 1, it's easy to put it as 1 over 1 minus 1 over p. So our LCD, least common divisor of 1 and p, is p. Okay, so that will be our common denominator. So the second fraction has already that p in the bottom. So 1 over 1, you want to build equivalent fraction which have p in denominator. So what we're going to do, we multiply top and bottom by p. So 1 times p will give you p. So 1 over 1 minus 1 over p, it's the same as p over p minus 1 over p. And now we have common denominator, copy that p down, and subtract numerators. So we end up with p minus 1. So this is numerator. Okay. Step 2, simplify the denominator. And of course, by now we know that we need to get common the denominator. So you have PW plus W over P. So you need to find a common denominator of W and P. So LCD, least common divisor of denominators which we have, which is W and P, is W times P. Since we can't factor them, so to get that LCD, you just multiply those denominators together. So LCD will be W times P. So next, what you're doing, again, I'm not writing those steps because I put them before into examples. You're creating equivalent fractions. So you take that P over W and you need to create equivalent fraction which has W times P as a denominator. So like you see, we already have W. The missing factor is P. So we're going to multiply top and bottom by P. And now we multiply numerators. So you have P times P. And P times P will give you P squared over W times P. So P over W, I will just show here that P over W is the same as P squared over W times P. Plus, I follow this, plus. Now I need to build equivalent fraction. Okay, so this is what we're working right now. W over P So you take that W over P and you build equivalent fraction, which will have W times P as a denominator, because that's what is our LCD. So we already have P in the bottom, so the missing factor is W. So I multiply bottom and top by W. So now we multiply, we have W times W over P times W, which is the same as W times P. So W times W will give you W squared over WP. So the fraction W over P is the same as W squared over W times P. Okay, so now what we can do here, we can add those fractions together. We have common denominator, which is W times P, and add numerators together. So you have P squared plus W squared. So this part right here, This is our denominator of original complex number. So what we just did, okay? Numerator, 1 minus 1 over p. We simplify, we did all those steps, this is what we end up. The denominator, pw plus wp, we simplify, and this is what we end up with. So now we'll apply keep, change, flip. Step 3, rewrite the complex number using simplified form of the numerator and denominator. Okay, so numerator, we have p minus 1 over p. Fraction bar. The denominator, it's p squared plus w squared over wp. Okay, so we rewrite the complex number using simplified form of numerator and denominator and apply keep, change, flip. So this is our shortcut, okay? Keep numerator. So p minus 1 over p. So we keep numerator. Change means change this division to multiplication. And flip will be flip over the bottom fraction. So we're going to flip this one. So wp times p will go on the top, and p squared plus w squared goes on the bottom. And now you have fraction multiplied by fraction, which means we multiply numerators together. Be careful, you have expressions, so put them in a parentheses. So we multiply, and multiply denominators. So we have p minus 1 times w times p over p times p squared plus w squared. Since you have a multiplication, you're ready to cancel repeating factor. So repeating factor, it's p, and technically that's it. Okay, there's nothing else what you can cancel. Okay, p minus 1, everything what is in the parenthesis, you keep that, you treat that as one expression. So you will rewrite the final answer as p minus 1 times w over p squared plus w squared. And that's your final answer. There's nothing else what we can do. We technically could distribute that w in numerator, but I just recommended to keep it as a product of factors. Okay, I have 3 more examples for you guys. Let me just check how much time I'm recording, if the video is not too long. Done. 34 minutes. I think we good. So let's just continue. We'll do 2 more examples. So this is example 4. example 4. So, of course, simplify complex numbers. Okay. Complex fractions. Okay, so we have z over 3 minus 3 over z over 1 plus 3 over z. Let's do this one. Oops, this one looks like 2. 3 over z. Okay, so again, this is the middle, so this is the major fraction bar. And we have numerator and here we have denominator. Okay, so first we're going to simplify. Numerator, which is z over 3 minus 3 over z. Okay, so we need to find common denominator. So LCD of what you see in the denominator, which is 3 and z, is 3 times z. Since they are both prime, you cannot factor them. So LCD, it's 3 times z. So we're going to rewrite 2 over, not 2, that's z. See, I'm even getting confused. Rewrite z over 3 and 3 over z using common denominator. Which is 3 times z. Okay, so z over 3, we need 3 times z as a common denominator, so we have 3 already. We need to multiply top and bottom by z. So that will give us z times z over 3 times z, which when you guys simplify, you will end up with, just put that as a z square. My 2 and z looks almost the same. I don't want to confuse anybody. Z squared over 3 times z. Okay, so that was the first one, z over 3 right here. Now I'm going to simplify, build equivalent fraction to 3 over z. Try me better. 3 over z. So I need my common denominator, which is 3 times z. So we already have z, so we're missing 3. So we multiply top and bottom by 3, and then we multiply 3 times 3. So 3 times 3 will give us 9 over 3 times z. So that's the fraction 3 over z. 3 over z. Okay, so now let's simplify that. So we have z over 3, which is the same as z squared over 3 times z, minus 3 over z, which is equivalent to 9 over 3 times z. Okay, so now you can subtract those fractions because we have common denominator. So copy the common denominator, which is 3 times z, and just work with numerator. So you have z squared minus 9. Okay, so what I want you to do here just go back, z squared minus 9. I want you to factor. You have to simplify completely. So I want you to factor this numerator. So z squared minus 9 is the same as z squared minus 3 to a second power. Hopefully you guys remember the formula a squared minus b squared, difference of two perfect squares. And when you have a difference of two perfect squares, you factor this as a minus b times a plus b. So in our case, we're going to have z minus 3 times z plus 3. Okay, so again, this is still our numerator. Let me rewrite the top part of the fraction z squared minus 9 using factors. So this is the same as z minus 3 times z plus 3 over 3 times z. Okay, so this is numerator. I simplify numerator of the complex fraction. So this is numerator, the green one, okay? Numerator of the complex fraction. Now what I'm going to do, okay, I'm not writing steps, I'm explaining them. I'm going to simplify the denominator. So simplify the denominator of the complex fraction, original complex fraction. So denominator was 1 plus 3 over z. So here, guys, since you have a 1 is the same as 1 over 1 plus 3 over z. Like you see, our common denominator will be z. We need that z. So when you have 1, you should just rewrite that 1 as z over z. Like you see, z divided by z will give you 1 plus 3 over z. So 1, you can just make it anything you want it as long as it has the same expression or the same number on the top and on the bottom. And now we can simplify that. We have z as a common denominator, so just add numerators. You'll end up with z plus 3. Okay, so this is denominator of the complex number. It was an orange. So this is the denominator of the complex fraction. Step 3, rewrite it. That's the third one. Third, rewrite numerator and denominator of the original complex fraction using the simplified form from step 2 and apply keep change flip. Okay, so we're going back. Numerator, it's z minus 3. Z minus 3 times z plus 3, right here. Z minus 3 times z plus 3 over 3 times z. Okay. Let's go back to our complex fraction. Division. So the pink division over. Now denominator, we simplify, that was in orange, z plus 3 over z. Okay, and again, recommended the binomial, keep it in parentheses. And now we apply keep, change, flip. Keep the top fraction. So we have z minus 3 times z plus 3 over 3 times z. Change this division to multiplication. Flip the bottom fraction, which means z goes on the top, z plus 3 goes on the bottom. And now you have fraction times fraction, so you multiply. You multiply numerators together, and you multiply the denominators together. So just multiply. Don't distribute anything. You're trying to cancel actually repeating factors. So don't add extra work to what we have already. So we have z minus 3 times z plus 3 times z over, that was multiplication here, 3 times z plus 3. So again, don't distribute because you always should be able to cancel something. So factors which repeat, z plus 3, it's on the top, z plus 3, it's on the bottom, cross them out. And you have z on the top, z on the bottom. So our final answer will be the remaining factors, which is z minus 3 over 3. And this is the final answer. I do understand that those problems takes time to solve it, okay? Because we have very complex, that's why they call them complex fraction, very complex numerator and very complex denominator, which you need to simplify and then by the end simplify that final fraction, okay? One more example and we will be done. Okay, so example 5, I think. Okay, so simplify. This is my last one, the complex fraction. Practice, practice, practice. Okay, so what I recommended, when you guys think that you got it, okay, you're pretty confident about the lecture, okay, you can copy the example in your notebook and you can just try to solve it by yourself and then compare with my solution. And in case if you didn't get the correct solution, just go back, okay, check the explanation, find your mistake, okay? You technically are responsible right now for your study. So I'm not writing any steps, but what I'm going to do first, I'm going to simplify numerator. So that numerator is 4 over p minus 3 plus 1. So this is nice case because when I have plus 1, that 1 I can make it anything I wanted as long numerator and denominator are the same. So I really need p minus 3. So I'm going to change 1 to a fraction p minus 3 over p minus 3. Okay. So now I have my common denominators, which are p minus 3. So copy denominator once and add numerators. So we have 4 plus p minus 3, and that will give you 4 minus 3, which is 1, plus p over p minus 3, which I'm going to rewrite as p plus 1 over p minus 3. So let me say that this is numerator. Okay. Next, what I'm going to do, I'm going to simplify the denominator. So denominator is 1 plus 2 over p minus 3. So the same thing, since I have 1, I can create equivalent fraction, which will be p minus 3 over p minus 3, because that's what I have in the denominator of the second fraction, plus 2 over p minus 3. So now we have the same denominators, so copy denominator once and add numerators. So we have p minus 3 plus 2, and that will give us p minus 1 over p minus 3. Okay, so this is the denominator of original complex fraction. So now I'm going to simplify, so I will move here, numerator, which we simplify, 4 over p minus 3 plus 1 here. This is the same as p plus 1 over p minus 3. The major fraction bar, and denominator in orange, which we simplify, this is the same as p minus 1 over p minus 3. And again, I recommended parentheses, so you guys know that we're dealing with expression. So now you have fraction divided with, by fraction. Okay, fraction divide by fraction. So apply, keep, change, flip. Keep the numerator, okay, which is p plus 1 over p minus 3. Keep it. Change this fraction bar to multiplication and flip, so change, flip the bottom fraction, which was the denominator of the complex number. So p minus 3, it's on the top, p minus 1, it's on the bottom. And now we multiply fraction by fraction. So this is what we're doing. We multiply numerators together, and we multiply denominators together. Don't distribute, don't FOIL, please don't do that. Just keep always as factors. So you have p plus 1 times p minus 3 over p minus 3 times p minus 1. So again, don't FOIL, because if you solve it correctly, there's always going to be a factor which repeats on the top and on the bottom, which you can just cross out. So your final answer are the factors which are unique, which means p plus 1 over p minus 1. So this is our final answer. Okay, that's it. That was the last example from section 15.5. I believe this one was 15.5, complex fractions. Okay, it takes time when you guys starting. I really don't recommend just watching and listening to what I'm doing. I recommend it to have your notebook and try to solve it. Again, try to follow the direction which I'm giving you. Eventually, when you're getting more confident, try to practice the examples which I'm going over, which a lot of them, by yourself. And then if you're getting different solution, or you getting stuck, okay, you don't know what to do next, you have all the steps, okay, so you can go back to the video and resume it. Okay, thank you so much for watching. Stop recording.